Hello, everyone. So here's the remaining recording of lecture 2, and the first half you'll find it on Blackboard. Enjoy. So here are 3 notations that I want you to be familiar with. This one, U, and then facing down U, and there's 2 more. I'm going to give it to you in a couple of minutes. So first notation, the U. Do you guys know what this represents? So usually this notation is used for union. Okay? So what the word union means, it's the collection of everything. Okay? So union pretty much means the collection of everything. So if you have 2 sets,
Yes, you were going again. Your voice, I can hear. No.
guys, can you hear me?
Yes.
Yeah, I can hear.
Now we can.
Okay.
Off before.
All right, so let's hope it's gonna work. I think it's because of the weather. It could be that. I'm not really sure. Let's stick around and hopefully it'll get better. So I am close to my router. I don't know how else to place my router. So let's hope this will work. So back to where I was, U represents union. Now, what about the facing down U? Well, this stands for intersection. So what do you guys think intersection means? Any thoughts?
Where the lines meet.
Okay, so if you were talking about lines, then we can say where they meet. We're talking about sets, so we want to talk about what the 2 sets have in common, or 3 sets, depending on how many you're working with. So intersection pretty much means what do they have in common? What do they share? Okay, so we can say intersection would be common elements. Okay, so we have union, we have intersection, and next thing is this symbol right here. That symbol stands for empty set. Another way to write this would be to put 2 braces like that and nothing inside. These 2 symbols will represent empty set. So if 2 sets have nothing in common, then we would represent as the empty set. Okay? So these are the 3 notations I want you to be familiar with. Now let me give you an example to work on. So here is an example. We have 3 sets, and I want you to find their intersection and union. So here you go. So S is equal to the set containing elements 1, 2, 3, 4, 5. T is the set containing 4, 5, 6, 7. V is the set containing 6, 7, 8. And you have to find what is S union T, what is S intersect T, and S intersect V. So go ahead and find those new sets. I'll give you guys 1 minute to do that, and then we'll go over it together.
Professor, I'm kind of confused on how to do this.
So I'm going to go over it in a minute. Just let's give everyone a chance.
All right.
But you want to understand these symbols before you start working on them. Okay, so let's go ahead and do that. So first one, we want to find what is S union T. Now, what did we say about union is? Well, union is collection of everything. So everything that's in S, everything that's in T, it's going to be in the union, okay? So S union T would be the set containing everything that's in S, which is 1, 2, 3, 4, 5, and everything that's in T. So T has 4 and 5, 6, 7. Well, I already have 4 and 5 from S, so I'm just going to list what's missing, 6 and 7. So that's what S union T would represent. So it's a new set, but it's the union of S and T. Any questions on that? Make sense?
Confused. I don't understand what you just did. Sorry.
So I said U means collection of everything. So if you're looking at two sets, when you union them, meaning you're including everything from first set, everything from the second set. So we're looking at set S, which contains these elements. And then I want to union it with T, which is this set. So you just put them all together and you create a new set.
Okay, so you're just writing everything in between.
Exactly, because union, that symbol, really means what's in S, what's in T, put them all together. And that's exactly what I did. I put everything from S, 1, 2, 3, 4, 5, and then everything from T, 4, 5, 6, 7. But because 4 and 5 wasn't in S, I don't have to repeat them because it's the same element. You just list them once. Any questions? Make sense so far?
Yeah, so the V doesn't go with that, right? Because they're now looking for the V.
All right, so V is another separate set. We're just looking at S union T.
Okay, got it.
I have a question.
Go ahead.
So what if 4 and 5 was not in T? Would we just add 6 and 7, or does 4 and 5 need to be there?
Well, if 4 and 5 was not there, that's fine. You're still gonna have to put 4 and 5 because it was initially in S.
Okay.
Mm-hmm.
So what if 4, 5, and 6 weren't there?
Then you only list 4, 5, and 7.
So union is literally just everything combined?
Yeah, everything from
Okay.
S, everything from T. Mm-hmm.
Okay.
Yeah. You got it.
Miss, I have one more. So if you have double, right? So you basically just write it once, right? So you don't have
Exactly.
to
You got it. So if an element repeats, you don't have to repeat it because it's the same thing.
Okay, got it.
Uh-huh.
Makes sense.
Good. Now, what about S intersect T? Well, what's the intersection means? Well, the intersect means what's in common. Okay. So S intersecting T would only be the list of elements that belongs to S and T. So what are those elements? Or if
4
there
and
is
5.
any?
4 and 5.
4 and
S,
5.
4 and 5, and for T is 4 and 5.
Yeah. So there we go. So that's the set of the intersection. Any questions so far? Now let's take a look at the last one we're constructing. Where's S intersecting V? So now you look at V and you look at S and you look at what do they have in common.
They don't have anything in common.
Empty slot.
Empty set, right? So you can put it like that, or you can just say braces with nothing inside because they have no elements in common. Any questions on this? Okay, so that's pretty much how we use these three notations. We use union to represent collection of everything from both sets, or if you're working with three, collection of everything that belongs to all three sets. And intersection is only what they have in common. And if they have nothing in common, then you represent it using the empty set. Now, knowing this, now we can start talking about what's an interval notation and inequality notation. Okay, so let me show you interval notation. and inequality notation. So these are just two different ways of representing a set, but they're the same thing, okay? They're just different ways of representing same set. So I'm going to show you what are the symbols, and then I'll show you how to use them, okay? So for interval notations, the symbols we're going to use are parentheses and bracket. And sometimes you can use mix, either one side is open, one side is closed, depending on what set you're looking at. For inequalities, as you all know, we have 4 inequalities. We have less than, greater than, less than or equal to, greater than or equal to. So these are the 4 inequalities we have. Now, every time you're talking about a set, you have to make sure, is the endpoint open or is the endpoint closed? So let me show you an example to illustrate how to work with something like this. So take the example, the set of x, where x is greater than 2, okay? So x is just a dummy variable. It's just representing a real number. Now here's the restriction. I want x to be everything greater than 2, okay? Now, I'm going to draw this set for
Miss, you
R.
are this.
I'm disconnected.
We can't hear you again.
Okay, hold on a second. Can you guys hear me now?
Yes.
Yeah, okay. So I think I got disconnected for a couple of seconds and then I'm back. Yeah, I don't know why it's happening today. I'm so sorry, guys. Okay, so let's hope this is gonna work. Again, let me know if you have trouble hearing me. So I was trying to draw this set where x is everything greater than 2 on the real line. So we are, thanks Amal. So 2, where's 2? Well, let's suppose 0 is here and 2 is here. Now, if you look at this inequality, it's greater than, right? It's not greater than or equal to. So that means that this endpoint is open. So we're going to put an open circle at 2. That's what the less than and greater than means. So this symbol means your endpoint are open, okay? And if you have the equal to sign on the bottom, then the endpoints are closed, okay? So that's how you distinguish when to include the endpoint, when not to include the endpoint. Now, we're looking at x, meaning a real number that's greater than 2. Well, which direction do we have greater values? Well, as you continue on, this is 3, 4, and so on, right? All the way to plus infinity. So that means we're looking at the set in this direction. So that's the set where x is all real numbers that are greater than 2. Does that make sense so far?
Yes.
Yes.
I have
Yeah.
a question. I have a
Okay.
question.
Go ahead.
Could you go over what you said about endpoint closed and endpoint open on the lesson signs again?
Yeah. So this right here, this is what we call an endpoint. Meaning it's where the interval is gonna start or it's gonna end. In this case, this is where the interval is gonna start because we're looking at 2, but we're not including 2. We're looking at everything greater than 2. So that's why this endpoint is open. Now, if I put just equal to on the bottom, change the inequality to that, that makes my endpoint close because now I'm looking at the set starting from 2 and going to infinity. So that's how you know when to include the endpoint, when not to include the endpoint. So your inequality pretty much tells you if you're including it or if you're not including it.
Okay, thank you.
No problem.
Miss, one more question.
Sure.
The one with the greater than, less than on the equal sign at the bottom. How do we call those again? I forgot.
So this one is less than or equal to.
Oh yeah. Thank you.
And then this one would be greater than or equal to. So you can be greater or it can be equal to that endpoint. Okay, cool. Good questions. So now I have the drawing of the set. Now my goal is to translate that into the other notation, which is interval notation. So you're gonna have to use either parentheses or brackets. Now, again, if you have less than or greater than, you're gonna use parentheses. So this will means open endpoint. Okay, again, if you have less than or greater than, you're gonna use parentheses. And if you're including the endpoint, meaning less than or equal to, greater than or equal to, you're gonna use closed endpoint. Okay, so you can think of parentheses goes with less than or greater than, and brackets goes with less than or equal to, greater than or equal to. In our example, we have less than or greater than. We don't have equal to, right? So that means we're going to use parentheses. So every time you write a set, you always have to go from lowest to highest because the real line is in order. So we start with 2 and then we go to infinity. So that means in interval notation, we're going to write this as open at 2, so 2 parentheses, and we're going all the way to infinity, so infinity, parentheses. So that's the same representation of the set, but in different notation. And we call this notation interval notation. Now, if I were to change this question just a little bit, say I give you x is greater than or equal to 2, how would I write that in interval notation?
You would have to use the brackets, yeah.
Bracket at 2. So if you were to draw this, it's going to look something like this. So suppose 0 is here, 2 is here. Because of the equal to, we include the endpoint. And it's greater than, so greater values are on this side of the real line. So we start at 2, bracket at 2, and then go to infinity. Now infinity always gets parentheses. Do you guys know why we always put parentheses around infinity and negative infinity? Why don't we put brackets? What do you guys think?
It's open-ended, it goes on and on.
Yeah, right. You only put bracket if you're including that point, but infinity is not just one number, right? It goes on forever. We don't know where to stop. So it's just an indication it goes forever on the right side. That's why every time you have infinity or negative infinity, you always have to put parentheses. The only time you use bracket is only when you're looking at a specific number. Like here, we're looking at 2. So x is greater than or equal to 2. So it'll be 2 bracket, comma, up to infinity, parentheses. So any questions on this? Okay, I have a couple more examples for you to work on. So take a look at this example, and then I'll go over them with you. So I'm going to copy them here, and we'll work on these. Okay, so I'll give you guys 2 minutes to work on these. You can draw the sets on the real line if that helps you to understand them better, but you don't have to draw it if you don't want to. Unless the question says to draw, then you have to draw it. So let's call this 1, 2, 3, 4. Okay, so take 2 minutes, work on it, and then we'll go over it together. Okay, so let's go ahead and work on these. If you haven't finished, that's fine. Just check your answers with mine for the ones you have finished. So for the first one, we have the interval notation, and we want to represent it using inequality notation. So what do you guys have? So inequality notation, meaning you have to use the less than or greater than symbol, okay? So if I were to, go ahead.
I was gonna say I have x is greater than 3, but I'm not sure if that's correct because it's negative.
So that's a good point, right? It has negative infinity. So if you were to draw it, it will look something like this. So this means this endpoint is open. You agree with that?
Yes, because it doesn't say equal.
So put an open circle. Which way is negative infinity? Left or right of 3?
Left.
To the left. So this is negative infinity. This is plus infinity. Now, if you want to number more points on the real line, you could do it, but I think I'll put it here. I could put 0 here just for convenience. So we're going to the left. So our set is represented on this side. Okay, now tell me, how do you write this using inequality notation? So go ahead.
I don't know if it's right, but I put negative x, right? And then I put is less than 3. That's what I did.
So Julie, you're almost right. But remember, x is a dummy variable, so you don't have to say x is negative. We have the less than and greater than to indicate negative numbers. So Emily, let me see what Emily. So Emily says x is less than 3. Monsieur, what do you have?
So I say the x, no, 3 is greater than x, which is minus infinity.
So if you say x is less than 3, or if you say 3 is greater than x, both of these are correct. 3 is greater than x is equivalent to saying x is less than 3. Again, x represents your dummy variable. So x is all of this. So it is everything that's less than 3. So that's why this will be the correct interval inequality notation. There's another way to write this. If you've done WebAssign, you might have seen it. Have you guys seen this in WebAssign?
Which one?
I've seen it, but I haven't done it yet.
Okay, so on WebAssign, you would see something like this. Negative infinity, less than x, less than 3. That's also acceptable. Okay, so any of these are fine. So this would be the inequality notation of this same set. Any questions? Make sense so far? Okay, moving on to the next one. So answers in the chat. -3 bracket infinity. So I saw this one, -3 bracket infinity. Anyone else?
So it would be a closed circle on -3, and it would go, the arrow would go in, it would go in the right direction.
Yeah.
So the thing is, I think -3 is, I mean, the infinity is, or x is greater than negative.
X is greater than -3.
Greater than or equal to.
Yeah. So x is greater than -3, or x is greater than or equal to -3. Yeah. So this is correct. So you start at -3 and then you go to infinity, including -3, because we have equal to here. So this is correct. Any questions on this?
You always put the lower number first. Is that right?
Yes, so you go from lowest to highest. Good point. Now, what about number 3? So we have the interval notation, and we want to write it using inequality notation. Now, for number 3, because you have real number, we don't have the extension, meaning infinities in there. So I'm going to go ahead and draw it. So here's the real line. We're looking at the set between 6 and 9, not including 6, but including 9. So suppose 6 is here, 9 is here. And 6 is not included, so it's open because it has parentheses. 9 is included, so it's going to get a closed circle because of the bracket. And we're only looking what's in between. So that's where your X is. So how would you write this using inequalities?
Isn't it like the 6 is greater than 9? Because 6 would go like, it get bigger number each and every time.
Well, X cannot be greater than 9. Greater than 9 is right here.
Miss, I put X is less than or equal to 9. Yeah.
Yep. So you can, so there are 2 ways you can say this actually. You can say X is greater than 6 and X is less than or equal to 9. But usually we don't like to put 2 sentences. This looks like 2 mathematical sentences. You want to put it in 1 sentence. So the way you're going to do it is X lies between 9 and 6. That's how you put it together. So this symbol belongs to 6 because 6 is open. And the next symbol, the less than or equal to, belongs to 9 because the endpoint 9 is included. So that's how you would represent this set right here. So another way to say it is X lies between 6 and 9. Any questions?
Yeah, can you do that again?
So pretty much when you have 2 numbers like this.
I'm sorry?
Can't hear you.
Can you hear me now?
Yep.
Yeah.
Okay. All right, so I think it's working now. Okay, can you guys hear me?
Yeah.
Yep.
Okay. All right, so I'm back again. So we know X is right here, right? It's just a dummy variable. X lies between 6 and 9. So the way you're going to represent it is by putting less than or equal to 9 and less than 6. Well, less than X. So 6 is less than X or X is less than or equal to 9. So if you have X lies between 2 real numbers, you just put less than and less than in between. Any questions?
So it only works on 2 real numbers, right?
Right, because X is lying between 2 real numbers. There's no infinity involved.
Okay, that's what I understood here.
Yeah. Did someone else have a question?
Yeah. I wanted to ask, so for the test, how would you recommend us to write it if we get a problem like that?
So
Like number 3.
just like that. Just like that.
Okay.
If you have 2 numbers, say A and B, and X is between them, so X is less than B and then greater than A, which you can say A is less than X, less than B. Now, I will show you a picture in a little bit, so that way you can see the general way of writing this. But really, if you have this type of set, you know your X is between these 2 real numbers. So you just put the less than symbol on both sides. Okay, now what about the last one? Now for the last one, we do have to do a little bit of work because you have 2 sets and you're only writing down their intersection. That's what that intersection symbol is. So for this one, I would strongly encourage you to draw, okay? So let's call this set A, and let's call this one B, okay? So A is the set from -infinity to 6, including 6. And B is the set from 2 to 7, open. And we're looking for what is A intersect B. That's what this question is asking you to find. And again, we said intersection means what do they have in common? Now, if you have something like this, you always want to draw it. So let's draw both of these sets and find out what they have in common. So A is going to be -infinity to 6, including 6. So let's take a look at what that it looks like. So let's suppose 6 is here and it's included, right? So everything to the left is A. That's A. Now what about B? Well, B is from 2 to 7, right? And they're open. So let's suppose 2 is here, open, and 7 is here, open. So that's B. Now, where do they intersect? Well, if you look at the picture, they intersect right here. That's where they intersect. From 2, right? 2 to 6. So they intersect here, open at 2, and up to 6, close at 6. So A intersects B is open to all the way to 6, including 6, because 6 is included in both sets. But 2 is not, because set B doesn't have 2. So for something like this, you always want to draw it and then find out what's in common and shade that in and then write down the intersection. Any questions on this?
How would you notate the intersection?
This symbol right here, that means intersection.
No, but I mean, when you represent that, it's the, oh, I see it. Never mind.
Nope. Okay. All right. So I have 2 sets, A and B. I'm just going to overlap them, and that will be the intersection. Okay. Well, go ahead. Let's go one at a time.
I was saying, like, on a test, that's how you would graph it. Like, if you asked to graph it, that's how you would do it.
Exactly.
Okay.
Yeah. I heard someone else had a question as well. You can go ahead.
Yeah, I had the same question. So
okay.
If we want to find like, you know, the intersection, right? So we basically need to break it apart, or like, you know, make it like, you know.
Right.
Okay,
so you would graph
right.
each set and then collect the intersection. Okay. Now I do want to show you guys this image. This pretty much breaks down how to draw these sets when you have infinity in the picture and when you're just looking at a closed set or just an open set. So this is how you would draw specific sets. So for the first one, let's call this one number 1. You have 2 numbers, A and B, and both endpoints are open. So your X right here, X lies between A and B. So you can say X is less than B and then A is less than X. Pretty much you would read this as X lies between A and B. So that's what the description here represents, okay? And that's what we spoke about previously when we worked on this example, number 3, that when you have 2 real numbers as the endpoint, then X lies between them. So you can use the less than symbol or less than or equal to if the endpoint is included, okay? So this chart kind of summarizes that for us. Now, for the second one is when both endpoints are included. Again, you're looking at 2 real numbers as the endpoint, and both of them are included. So you close in those circles at the endpoint. So now X lies between A and B, where A is included, B is included. So you would write less than or equal to symbol like that. Now, well, the third and the fourth is just what if one endpoint is open and the other is closed, okay? For the last two is just looking at infinities, okay? What if the set goes on forever? And what if there's a endpoint that is closed at the one end and the open, okay? So pretty much this chart summarizes everything for us. Any questions so far? So Kevin, to answer your question, no, we don't have to put greater than greater than. If you put less than, that's good enough. When you're looking at where x lies between two numbers, use the less than symbol or less than or equal to. Okay.
Miss,
yeah.
Are the tests are not open books, right?
Correct. They're not open books. You come in, don't bring anything with you other than your ID and COVID verification stuff, but don't bring any notes in. No calculators as well. Okay, so continuing on with our lesson. Now, the next thing I want to mention is about absolute values. Now, here is one way we can define absolute value. So this is the last bit of P2. So absolute value. So have you guys seen this, say absolute value of x, these two vertical bar, and there's something inside?
Yes, doesn't it mean that the value is going to be positive?
Exactly. That's exactly what it means, okay? So absolute value is represented by these two vertical bar. Whatever is inside, the result is always positive. So we like to think absolute value as the distance function, okay? Because when you're measuring distance, you want to say the distance is positive. You don't say, I travel negative distance. That wouldn't make sense, right? So unless you're saying, oh, I travel south, but that's negative. If you want to think of it that way, that would be a different thing. But we want to think of as positive distance, okay? So absolute value is defined as a piecewise function. So we have absolute value of x is equal to x if x is greater than or equal to 0, and it's going to be negative x if x is less than 0. So really, whatever you input into this definition, the result is always positive. For instance, if I am looking at, say, absolute value of -3 times 2, well, that just means I multiply the number and take the absolute value of it. So this is -3 times 2, that's -6 inside the absolute value. And I take the absolute value of this, that's just 6. Pretty much a simple example just to illustrate the idea, okay? Another way to see it is as a distance function on the real line. So if you look at two real numbers on the real line, and if you want to measure how far they are, you can do it this way. So this is a notation we use. The way you would read this is the distance between A and B. So A and B are just two arbitrary numbers on the real line. So D parentheses A comma B, that reads as distance between A and B, is the absolute value of B minus A. So this is another way we can define the absolute value. Let me give you an example. Now, sometimes you just want to remember that concept, but if you do want to draw it, that's fine. With smaller numbers, we can draw it by hand, but with bigger numbers, you just want to use the formula. So if I want to find how far the numbers 8 and 2 are, well, I would have to kind of use this formula, right? Or you can draw the numbers 8, -8, and 2 and just count how far they are. So the distance between -8 and 2 is equal to 2 minus -8. Simply using the formula. So this would be equal to the absolute value of 2 plus 8, like we said, properties of negative reals. If you have double negative, it's positive. So 2 plus 8, that's going to be 10. So absolute value of 10 is simply 10. So the distance between the numbers negative 8 and 2 is 10. Now, if you want to draw them and count each step, you'll see they're 10 distance apart.
I have a question.
Sure.
So why can't it be 8 minus -2?
You
Instead
could
of
do that too. That's same thing.
it'll be the same. Okay.
Yeah, because if you do negative 8 minus 2, you get negative 10. And then you take the absolute value because that's the purpose of it. Yeah, you got it. Good.
So yeah.
So you can switch them around as long as you're underneath the absolute value or inside the absolute value. At the end, you get positive 10. So you could do negative 8 minus 2. That'll be negative 10 in absolute value. And that's going to be positive 10. Okay. All right. So know the definition of absolute value and know that you can use it as a distance between two numbers, and that's the formula. Okay. So that will conclude P2 for us. Any questions?
So Miss, for the absolute value, right? If you get like minus, like answer, if you get the answer is minus, right? If you have the absolute value, it just changes to positive, even though it's negative.
Well, if you're looking at, say, the distance between 2 and negative 8, you will do negative 8 minus 2 inside the absolute value. So that will give you absolute value of negative 10. And then when you take the absolute value, that turns into a positive 10 because we're applying the absolute value to it.
Yeah, that's awesome.
Yeah. Okay. All right. So let's continue on. So we have just a little bit more time. Let me just give you the introduction to the next section, and then we'll do more next time. I don't have too much time left today. So P3 is next. And on P3, we're going to study integer exponents. So I will define what is an exponent, and then P4 is going to talk about rational exponents. So really, P3 and P4 are almost the same idea. The only difference is P3 only focuses on integer exponents, meaning when the exponent is a whole number, whereas P4 only talks about fractional exponents. So when your exponent is a fraction, okay? But the properties that you see on P3 will carry over to P4. So just keep that in mind. Now let's define what is an exponent. So definition. So if I say, so let A be a real number, okay? And suppose you have A to the power n, okay? So here, A represents your base and n represents the exponent. And sometimes you can also call it power. So what this really means is you have A repeated n times. So A is going to appear n times. That's what the idea of an exponent is. So really you have A times A times A times all the way up to n times. So A appears n times. That's the basic idea of what an exponent is. Let me give you an example to help you understand this. So suppose you have 2 to the power 4. My base is 2, my exponent is 4. So 4 is going to multiply itself. Go back. 2 is going to multiply itself 4 times. So the way you would expand this would be 2 times 2 times 2 times 2. So 2 appears 4 times. That's how you expand it. And then you just evaluate, okay? We know 2 times 2, that's 4. And then 2 times 2, that's another 4. So 4 times 4, that's 16. So 2 to the 4th power is 16. Does that make sense?
Yes.
Okay, cool. Now I will give you the properties of exponents next class, since we don't have time left. Pretty much the idea is to understand this definition, and then we have some properties for sum and difference and power, and we also have negative exponents as well. So we're going to deal with that next time, but for now we're going to stop here. I really encourage you guys to start working on WebAssign. Get started if you haven't, and start working on those assignments. I'll probably put up a quiz this weekend so you guys can work on it, and just, you know, suppose it's an actual quiz. How do you perform? Okay, don't use any resource, don't use any calculators, and also try not to use your notes. Treat it as if you were to take it in person. Okay, so we'll finish recording
I have
here.
last